So let's just drop a position node for the hunter as well. I just want to move him forward just a tiny bit, 0.5, so that when the crocodile's mouth is actually shut, he's in the mouth. Okay, that's when he gets caught. So let's set up our sim really quick. So yeah, for this part we'll just use the shelf tools. So for our hunter, for the body, okay, we're not going to be, obviously we'll simulate the cloth and everything separately. For the body, we're going to be using these new tetrahedral constraints. Okay, so I'm just going to click on that, click on the hunter, press enter with my cursor in the viewport here. You can see that it builds up our vellum solver for us. Okay, so let's go back out and see what we've got. So the hunter, let's see, it's all messed up. All this pointer form stuff, let's get rid of that because we'll build that later. Okay, so we've got a poly reduce. Okay, so obviously there we can see a problem straight away. That's being reduced too much. Let's do percentage, unless I don't know, you could drop it to 50%, whatever you want. Okay, just to simplify the geometry, but in fact, to be honest, we don't really need it. We got a remesh. Okay, so just like we used on the cloth earlier, let's try and make these a bit smaller. Just for the moment, we'll do that. Something like that. Okay, and then we got a solid conform. So at the moment, this is still a hollow geometry. A solid conform will convert this into tetrahedral shapes. So this is not happy. Let's see why. So we've got intersections, right? So that's probably because we've got, you know, all the different all these different overlapping geometries, right? So let's just, oops, get rid of that. Let's just delete what we're not going to be simulating with this. Okay, so we've got these groups here. So I want to simulate the body and the shoes, believe it or not. Okay, so let's delete non-selected, isolate them, remesh them. See, and now our solid conform is happy. That works. Okay, and then we got our constraints here. Okay, which are a little different, right? So you can see that they look like polygons now, actually. So they are basically trying to hold the volume and the whole shape of each of these. If I drop a clip node here, maybe that can see that a bit better. Raise this up. Okay, just to kind of chop our guy in half. You can see these are still quite big, but each of these shapes is like a kind of diamond shape. And these constraints are trying to hold that diamond shape, the same configuration as it is, and then that will give us you know, a kind of similar to an FEM simulation, right? Let's make these a bit smaller still here. Let's do these a bit 0.5 smaller. We'll probably play with that again a bit more in the future. So out of there we've got our geometry and our constraints. Okay, and then on the constraints we've got all these different attributes which come from in here. Okay, we don't need to worry about most of these rest matrices, vectors. Important ones probably stiffness you'll worry about more, and the type is important, but with this one you'll just have the one. Maybe velocities as well if you wanted to add velocities to the beginning. And then in the geometry here we don't have much, more on the point. So again we've got the mass, which will be varying depending on the size of each tet. the P scale, which will be the thickness, okay, which we can, I think, visualize. We can with some, yeah, visualize thickness. You can see there, as long as they're not overlapping, that's fine. Turn that off. Okay, and you can see there, just like the cloth, is the mass is being calculated. Okay, and that basically helps out when I add more subdivision to this, then the mass should stay relatively similar. The same with the thickness. Okay, and then we got a stiffness for our tetrahedrals. So let's take a look at our solver, what we got in there. So we got our vellum object, and this is trying to pull in the geometry and the constraints from the first and second inputs, which it doesn't have. Okay, so you can either source your geometry in here if you're working with a DOP network in the SOP context, or if you're doing out here, then you can use a vellum source and just grab it directly like this. Okay, which works fine. Let's just drop a ground plane so we can see if we actually get something that works here. Okay, I'll hide our crocodile for the moment. And let's see. Should get this smudgy, splodgy kind of human. There we go, great. Let's bring in the crocodile as a collider. So let's go to collisions, static object, and that should generate, yeah, my crocodile. Let's just take a look at him. There's the surface geometry and the VDB here. It's a bit coarse, so let's bring that down. 0.5, 0.2, a bit more. 0.1. And then, as I said, so the crocodile is going to be biting at, I want to start at about frame 40, so I'm just going to come out here, start frame 140, so we won't see anything at the beginning until, let's press L on my keyboard to tidy this up. Got the crocodile coming in here. Let's just see if this works. We'll skip all the way up to frame 39 to start. Let's see what happens. Crocodile's not moving. Always forget to do this. Use deforming geometry. And there we go. Well, it's not beautiful. It's kind of weird, but you know, it's something. We got something. So yeah, with vellum, pretty much always I'll be pushing up the sub steps, you know, pretty dramatically. With low sub steps, you're always going to get kind of stretching and weirdness with grains as well. Okay, so you can see that it's still stretching with 5. So I'll have to do some work to kind of solve that problem. Okay.